Okay, I'll be very brief. Good afternoon, welcome. It's my great pleasure to introduce a colleague and friend and someone who I greatly admire, Brooke Anderson, an associate professor at Colorado State University. Her sort of resume is very deep and varied. And just I reminded as I was looking at it that when I was a PhD student, I would always look at this Anderson et al. Study when I was in the UK, and there was always like, that's an amazing study, and it was about temperature and mortality in the United States, and it was this Brooke Anderson. So and we've worked together a lot on tropical cyclones, hurricanes, but also part of that is that Brooke is an amazing data scientist as well, and so like really excited about this talk. But I should also say that Brooke has a very creative side. So so Brooke is also a very talented drawer and illustrator, and you know, maybe you could talk a little bit about that at the end.
Definitely on my way.
Yeah. So a professor of many talents. So without further ado, please.
Sounds great. Thank you so much. Well, nailed it perfectly done. Yes, it's a great pleasure to be here today, and I'm really looking forward to talking about this topic. So a few years ago, I and some of my colleagues got an R25 to develop modules on reproducibility for the NIEHS. And we've been working on that, and it's been a wonderful chance to think a lot about the process of what we do and why some things work and why we might want to do that. So today, you know, this is a chance for me to talk and process some about part of what we're working on for those modules, but specifically this idea of how you organize your research files. And I think this is the kind of thing where it's a simple idea. The technical parts of doing it are very straightforward, although we'll talk a little bit about fancier stuff that you can do too. But the simpler part, you know, is very straightforward to actually do. But it can have real benefits. And it's the kind of thing that it's hard for many of us who think it has benefits to explain it. So I have a lot of colleagues who just like, they have a system and they will always use their system. But if you ask them about their system, it's hard to articulate. So hopefully today, we're gonna talk about a few things. We're gonna talk about why you should organize your research files. We're gonna talk some about how you should organize that. And you all have individual aims and goals for that. So I'm not going to say this is the one way. I'm going to talk some about how you think about that yourself. And then what can you do with the well-organized file, some of the fancier stuff. So we'll go through that. And again, this isn't meant to be kind of prescriptive about there's one way to do it. This is the one way to do it. It's more for you to think about this process and have some guidelines as you're thinking of your own framework. And also, if you already have a system, perhaps some talking points when you onboard somebody new in your research group about why they should also use your system. So we'll talk some about that as well. All right, so when I talk about research files, I'm really talking about the collection of files that you have for a project. And that might be, you might group it by a grant, or you might group it by specific papers if it's smaller ones. But these can include the research data sets that you collect, but also the code that you're creating for your analysis, and then things that you have as the output for that, reports and presentations, all of that. And you think like, of course, this is something we have figured out. But as you start as an academic, whether that's a student or moving into kind of a professor position, you just started as a professor, right? You realize that there are a lot of life skills that come with being an academic researcher that maybe don't get taught along the way. And you have to kind of figure out yourself as you go along. And I thought this was really interesting. One study, it's a little bit old now, 2007, but one study surveyed over 250 biomedical researchers at the University of Washington. And it was asking them questions about their research data management and their analysis to understand better what people are actually doing in the field. And they noted that a common theme surrounding data management and analysis was that many researchers prefer to use their own individual methods to organize this. And often there's not even a system that they use at all. So here are some quotes from it. One said, well, my files, they're not organized in any way. They're just thrown into files under different projects. And for another one, they said for their data, I grab them when I need them, but they're not organized in any decent way. So as easy as this is to technically implement, I mean, I think sometimes we just never get a system for it. And so you just put things somewhere convenient at the time, and then you don't think about it much until you realize that things are a little bit messier. So let's talk a little bit about why it's worth the time to do this, because it's not like it's free. It does take some time to think through at the start of something, how to organize and then to follow through with that. So the first one is efficiency, and I'm going to include some quotes. There's some very nice papers that people have kind of thought through this as well. I'm not the first person to think about this. So I put these in. I have a few references at the end if you would like to follow up, but if there are other ones in here, and Carolina, we're fine with sharing these if people would like the copies of these slides. But if there's something that I quoted in here with a name that you don't see the reference for, I'm happy to pass that on to you too. But one of the people pointed out that one of the things that is very helpful is when you are well organized, when you get to the point of writing your paper, there are sections of your paper that almost write themselves, which is the dream, right? Like we love that. And those are the methods in the data sections. So I put an example here. This is a real life directory from a student who worked in my research group. This was towards the end of her time with my group. I had really gotten this in by this point. And you can see things are very nicely organized. And it's to the degree that when she needs to go back and remind herself what data she's using, where do you go? You go to the data section. It's all there. When she needed to remind herself of what method she used for her analysis, where do you go? You go to the R section. All of the R code is right there. So she was able to very quickly go back and write into English everything that had been done. So it made it very efficient. It's also helpful when you are working in a large research group, which I think almost all of us work in collaboration. This is not a field of single author papers. So when you're working in a group and you need to bring somebody new in to understand what you're doing, this is, if you have it well organized, it becomes much more efficient to do that. You can onboard somebody new much more quickly. If somebody did some of the analysis and left your research group and you have somebody new who's going to continue the project, it makes it much more efficient for doing that. We'll also talk towards the end, when we get to the more advanced section, if you've organized it well, you can write tools that do some of the work for you. So you can write tools to a place where you expect them to be. So, I think for a lot of people, sorry, good? No, that's no problem.
What comes?
Can you hear us online again? Sorry, we had some technical issues momentarily. Yes.
Yes, great, wonderful. All right, so I mentioned this stuff because a lot of times you hear about organization, about reproducibility too. This is in that same pool, and you hear that you should do it because it's the good and right thing to do, and that is all true. Like that's all wonderful. The people that I know who really do it deeply and stick with it, like we feel good about it for that reason. But the real reason we're doing it is because it makes what we do a lot more efficient. Like we would not stop doing it if we could, because it works so much better that way. And I think the file organization is definitely in that pool of things. And of course, when you think about efficiency, here we have Back to the Future, one of my favorite movies, and my son's favorite movies. But the real person that you're helping in all of this is future you. Like when you do something and you take the time to do it right now, you're going to have to do it again someday. You're going to get the reviews back from the peer review, and it's going to be like 6 months from now, and you're going to have to rerun that analysis and figure out where everything is and figure out how to do it all. And so the biggest gain in this efficiency, I'm seeing nods, like I am preaching to the choir here. I'm putting it to words feelings you've had. It's wonderful.
Be kind to your future self.
Yes,
Yeah.
Be kind to your future self. And this is a key way to do it. Yeah. You want to be able to say, thank you, past me. All right, another thing. So this is a true image, and I felt a little embarrassed to take this, but sharing research files, you're more likely to share things if they're tiny. And I think Zoom backgrounds are pure proof of this. I'm not naturally a tiny person. There on the left is what my real background would look like if you ever did a Zoom conversation with me. On the right is what you actually see, and I think probably many of us do this. But one of the things that comes up about like, why don't people share their code and their data? And sometimes data have restrictions on them, but why don't people share their code when they publish a paper, right? Like that way we can see what they did. If you're doing it, you can use that as a starting point. You can check and see if your answer is different from their answer because of the way you went around it, right? So there are a number of reasons why people are sometimes hesitant to share their code. And one of them that comes up is like, they feel like they have to clean it up. And I've talked with people about this before, and they said, well, my code's not really in a state to share. And they don't mean that they think any of it's wrong. They think it's just messy. So we've got up here on the on the top, two examples. The right one is that student one that I was showing before. The left is also out of my research group with an earlier stage for a student. I won't share names to protect the innocent or the guilty, but you can see that like one of these maybe you feel more comfortable sharing than the other, and it's not that there's anything wrong with one or the other one. It purely comes down to like, well, yes, I feel like this is ready for public consumption. I feel that this is nice and tidy and neat. So I think it subtly removes that barrier to some extent too. It makes you psychologically feel more comfortable with putting up on GitHub something that you've done, which is better for science in general when we share that. All right, I wanted to talk too about some of the like deeper and again harder to express reasons for keeping things well organized. And for this, I want to use Adam Savage. Has anybody heard of Adam Savage? Yes, Mythbusters. So yes, he's one of the hosts on Mythbusters. He has this long career of like designing the props for Hollywood stuff. So, you know, the ship in Star Wars. I don't know if he was on Star Wars, but that kind of thing, like the mechanic who makes that. And he makes all kinds of stuff for Mythbusters. So he's the kind of person always in a shop, a mechanic kind of person. And he recently wrote a book that I think everybody who could read. And it does not talk anything about coding, but it's all very relevant. So it's called Every Tool's a Hammer. And he talks about the process of making things and making things in teams. And it applies so well to coding as well, because when we're doing stuff, especially with open source packages and things like that, we're doing that same kind of thing. We're not doing it mechanically with our hands in the same way, but so many of the processes go through very closely. And you talked about the creative part, like if you have questions, you can ask me that at the end, but a chapter of this is actually how I plan my sabbatical as well. This book has had a big influence on me, but he has a whole chapter where he talks about the idea of organization. And he talks about for a long time, he would just kind of leave his shop in a kind of chaotic state, and it didn't bother him that much. But at some point, he started organizing things when he left at the end of the day. And what he would do was, he's got a whole process for it. Like he would take everything, he would group it by type. If it had a place to put away, he would put it away. But the things that were out, he would like organize by type and then even have them kind of at right angles to each other. So it's this very precise way. And he came up with a name for it. He calls it knolling. But he talks in this book about how much this opened up space for him to be creative. Like he felt like he's doing things more efficiently, but he also felt like he had the mental space to think about the things that were the substantive part of the problem instead of thinking about like, where is this thing? Where is that thing? You know, it just created the efficiency. So here's an example. This has taken off a lot. I think people were already doing it, but in the Lego world, people will knoll their Legos before they start building, and then you can build it much more efficiently. This is Adam Savage. Again. All right, so just to recap, some reasons to organize your research files. First of all, you can do your research more efficient. This alone, I think, is worth your while if you're taking the upfront time to do things, the time you save later. You can introduce new people to the project quickly, whether that new person is somebody new to your research team, whether it's somebody reading your stuff after they've read your paper and they're reading your code, whether it's you a year from now when you've forgotten what you did. You're more likely to share files that are well organized, and that of course is critical for reproducibility. And then you have more of this mental space where you can focus on the substantive parts of what you're doing and not focus as you're doing it on the nuts and bolts of where things are. All right, so next let's talk a little bit about how to organize your files. And again, I don't have like one way to do it. I'll show an example of what people have suggested, but we're going to talk more about what to think about as you think about how you want to do it. The first thing, I do think that this is pretty important for a research project. All of the files should go in the same directory. I think a lot of people already do that, then it's maybe a matter of messing with the directory. But there are some research teams that I've worked on, especially large ones, especially where they are collecting data from different types of equipment, from different types of assays. So some biomedical immunology kinds of teams, where things might end up in different places, even on different computers. When you have things in a single directory, there are a few things that have, for instance, an advantage. The first, it's easy to set up with tools that help you. So do people use ORM projects here? Yes, you've all taken classes with Jeff, right? Yeah, Jeff is amazing. I love talking here because, yeah, his class, email him and thank him for his class because he's teaching you wonderful things. So when you do that's very nice and helpful to do. It centers on a directory. You put an R project like that you set up for a directory. So you need things in the same directory for that. It's also easy to set up version if you start using Git, GitHub, things like that. That also, same way, works with the directory structure. So you need things in the same directory for them to be tracked together. But the other thing is, I think that those directories, they kind of work like the pods. If people have heard of these pods, that might be more of a suburban thing. No, some yes, some no. Okay, very American invention. The idea is if you're going to move, you can get one of these things and you rent it and you put it outside your house and you can store things in it until you're ready to move. And then it just like closes up and goes on the truck and moves it. And that seems like slightly of horror here, which is an appropriate reaction maybe for pods themselves. But that's what a directory is on a computer. Like it's a place you store things until you're ready to move it or share it. And think about how easy it is to zip up a directory and send it to somebody, or to put the directory as a whole on Git or GitHub, or to put it up through Google Files or Microsoft Office or something like that. It's this perfect example of a place you can store things that is also portable and shareable. And so that makes it really nice and convenient if you have all of your things in that one place. All right, so once you're putting it in one place, let's think about how you organize stuff within that space. So there are two things to think about here. First of all, I should say, for this part of the project, I'm going to get into talking about organizing your files based on a template. So what I mean by a template is that you have some design for how you're going to organize them. And when you do this first project, you use that one. When you do your next project, you use that same design. When you do the next one, you do that same design. So you've got the same template of organization. And there's room within that to have some variation in the types of files that you have, and even the subdirectory structure to some degree and things like that. But to the extent possible that you are using the same system. So we'll talk about what you can put in that system, but I think more important than what you put in is the fact of having the same one for all of your different projects. And we'll talk some later about why that is helpful. So then there are two things for that. If you have a template, there is the physical template, and then there's the blueprint for it, conceptually what the template is. And one of those is easy to make, one of those is a lot harder to make. The easy one is actually the physical one in this case. You just make a computer directory. You put in the subdirectories that you want to have. If you want to have template files for stuff, you can put in template files, and I'll talk more about those in a little bit, but you set it up like you want it. And then when you're ready to start a new project, it's very easy. You copy it, move it somewhere else, and you rename it with that project name, and you're ready to go. And that's your starting point. So you can see here, this is an example that we did for these modules. And this is from an immunology lab where they're testing out drugs for tuberculosis. So in this case, we started out with the template. Our template for the directory structure includes some template files for collecting data. I'll talk more later about that, but this could be as simple as just the subdirectory structure. And then when you're ready to start a new project, you copy it. You can see that's copy. You rename it to the name of that study. And then you can start filling it up. And that's a very easy way to ensure that you're starting from the same structure every time. You don't have to look it up, set it up new. And that couldn't be simpler, right? Like you're making a very simple directory. You are copying it somewhere, like everybody knows that much about how to use their computer, I think. So yeah, very, very simple thing to do. So then the tricky part is deciding how you organize that and what goes in, like what kinds of subdirectories you put in. So as you're designing that blueprint part, these are three things I want to talk about. Think about it. To it. Think about the use. That's pretty obvious. Does it have space for the things that I'm using for this project? Think about the reuse. That's the idea that we want to use time after time. And then think about discoverability. So let's talk a little bit more about that. And we'll be quicker on the use and reuse because I think that these are fairly obvious. So two of the key things to think about here, first of all, is to group similar types of files together. And you can see this is an example we'll go into more deeply as we continue. And this is from a paper by Marwick et al. In 2018, and I'll get the reference for that in a minute. But this is a very simple example of a design that he came up with, and I think it's potentially a very good one. You can see that there's a section for data files. If you have a data file, that's where it goes. And then there's a section for analysis files, and those are your R scripts. So this is taking anything that's got that type that's a data in one place, and it's putting all of the ones that are scripts in another. And this could go further, like within data, if you have data from different assays, if you have metabolomics data, and then you have like kind of metadata for the experiment, and then maybe you were tracking something about like the animal that you used over the different times, you know, you could have different subdirectories for each of those types of data. And what happens is if you keep data that are formatted the same way together in a subdirectory, you can start to use tools in R to like read it all in and do all the same things to all of those files. And so that can be a very useful way to organize things, just by the way that things are organized. So the exact values are different in each file, but the setup for the files is the same in that subdirectory. The other thing is to name your subdirectories generically. So you can see these are very, very generic names, right? Data and analysis. This is great for reuse. Can you imagine any project you would do where you would collect data that you could not call data, or where you would do an analysis that would not be an analysis? By comparison, if you were doing this one experiment and you use census data and you name this census data, and then you do another one where you use Medicare data, like then you've got to change names and you've got to start changing things. So even though this feels simple to do, and when you're making it, you want to do something fancier because you're spending your time doing this, right? You want to feel like it's good. It's really good to keep these very generic because that helps with that reuse idea, and it helps allow you to have the same structure time after time. All right, so the other piece that's really key is discoverability. And this, again, is playing into that idea of like making it more efficient for somebody new to come in for your project. So this term comes from a book that came out, I think like 20 years ago now, but a really good read called The Design of Everyday Things. And it's really interesting because a lot of times when we think about design, we think about like iPad and, you know, like super fancy things. This talks all about the design of super simple things like doors. And it talks about the elements that make it so something is designed well or designed poorly. And in those cases, if something's designed well, like the success is that you just don't even notice it. You know, like it makes your life easier, but you don't even think about it. And the poorly designed things are really the things that stumble you as you go. And so this idea of discoverability is that somebody new can figure out how to do it right away. So one example he uses is a door. Hopefully everybody has seen this Far Side comic. I do love this one. So if you look at the door there, it's very discoverable, even though the kid can't figure it out. Like he should be able to, right? It's very discoverable. It's got a sign that tells you what to do, but it's also got a handle that shows you, you know, you've got that natural feel of like, okay, I'll do it here. It's even got the little hinge up at the top is by its nature showing you how things get. So this is a perfect example of something that should be very discoverable. And you want that same kind of thing. If you compare to like a very modern building with a door that's got kind of nothing on it, so it's looking very sleek and everything, it's very easy for those to like go the wrong way or not know which side to push or something like that. So when we look at this example that I was showing before, I think, again, that really hits that idea of discoverability. Like anybody, any of you have never seen this before, would you know where to go to start navigating with this? I mean, I think for most people who have done any kind of research, it's pretty clear if you're looking for the data set, one of the data sets that they had, you would know where to go right away. So it's got this key piece of discoverability. These are both two quotes from some of these papers, and both of them hit on this idea. The idea that a key principle is that another person can know exactly where to go to find things as soon as they start looking at what you have. So one of the things that helps is clearly there are those kinds of elements like labeling things well, the pull in the door, right? But another thing that really helps this is standards. And this can vary community by community, but it can make it so if you're used to something, it becomes very discoverable. Even if the first time you figured it out, maybe not so much. So I want to give some examples for this from a car to really make sure it hits home. So think about how many of you drive? I know it's not everybody here, so some folks. And have you rented a car before? Somewhere, yes, I can see that. All right, so if you drive, when you get in a car and you get ready to go, the steering wheel always works the same way. It might look different, but it always works the same way. You turn it right, the car will go right. You turn it left, the car will go left. That wasn't always the case. Some of the very early cars, they experimented somebody sails, right? You sail. They experimented some with rudders. Where like if you push it this way, your car goes that way, but if you push it this way, right, it goes up. Didn't take off, right? But you don't see like for all the designers like to change different things. You never see somebody who's like, I think it would be fascinating and innovative if I had the steering wheel operate the opposite way from the road. Same thing with the brake pedal and with the gas pedal, right? Gas is always on the right, brakes always on the left. You never get into a car and need to figure that out. So those are standards. And that's really important for the safety of that, because you don't want people having to figure out over again how to use it when they get in something new. Now, by contrast to that, am I the only person who has had to spend like at least 2 minutes, it felt closer to 5, trying to look for how to open the fuel tank on a rental car, right? It's not a safety issue, so I guess they felt they could play around with it, but there's not a standard place for that. And so you're used to it on your car, and maybe if you get in a car that's by the same, the same manufacturer, it might be in the same place, but sometimes they don't even have one. I mean, that was really the trickiest, but that one took Google to figure out. But it's so frustrating because it should be the simple thing that you don't even notice, and then all of a sudden you realize it's a problem. So if there is a standard for how to set something up in your field, if you use that standard, it makes things discoverable, more easily discoverable for other people in that field. Even if for somebody totally new coming in, it might not be that way because we do get used to using these things. So when you think about that, there's kind of a hierarchy to how you do that. If there is a community level standard, that's the one to go with, right? I'm not aware of any of those for file organization, but I'm going to talk a little bit about one that gets close to it, and that is basing itself off something that is a standard for a lot of people who work with our programming. So we'll talk some about that. If you don't have that though, then if there's a research lab standard, use that, because at least everybody in your research lab is interested in that. And then finally, you can get down to an individual standard if there aren't higher level ones. All right, so we were looking at an example from this Marwick paper before, and I think this is a really good read. If you were interested in this stuff, I would highly recommend reading this at some point, and I've included the full reference for it later. So they call these compendiums, like a research compendium, the directory and the organization of it, where you store all of the stuff for your research. And they built a structure that is based on the R package structure. Has anybody here written an R package? Come back into that workshop sometime. Yeah, I see one. Marky, you're good R programmers. I know that, and you took from Jeff, so you can all do it. So we'll do that sometime. An R directory feels very fancy, but the secret of it is it's really just a directory with files in it. And those files have the code and they have the documentation and all of that, but it's just a directory. And the way that it works is that it is organized with very precise rules. There are subdirectories that you can have. The files that go in it need to be specific types of files. You put things in very specific places. And so it's this rules of how you set it up that really define that. And then because things are in place, but they're always in the same place, if they're there, people have been able to write these tools that build the package based on that. Because you write the code and the code always knows where to find things in that structure. So that is an area where there's this kind of file organization that people have gotten used to who develop our packages. So he based his structure off of that. And I think that's the closest that we have to kind of a community structure. So this might not be the fit for you. That's a chance. But I do think, if you're having to pick one and you don't know where to start, this is a pretty good starting point. So in that, he's got a whole variety going from kind of like simpler to more complex. And again, all of them are built so that they are using the same kind of names and rules about where you put things as our packages. So we looked earlier at the very simple one, and that has data and that has analysis. And then it has two other files that are kind of top level files. One is the description file. With our packages, that's where you put things like what version it is and the rules for how you put it in, but that's where you put general meta information about the package. And so you can do the same thing with your project with that description file. And then the README is a more like that's more start here if you're new to stuff. And that's pretty general, a README file across a lot of different software, that you will have a README file for people who are building the software to come in and look at. And it's the Alice in Wonderland kind of thing, right? Like it's given a name that should be very clear. So just like she came across the thing that said drink me, look at eat me. Like this is the README. So when you're looking through, that was the message meant that this is where you start. And so that's where you can tell people how to navigate your project. As you go to the more complex ones, it's got some other ones that it's adding in. So this is a scenario where you might be starting to have functions that you're using a lot and you want to have them in a separate file rather than with like your R Markdown document or something like that. So it's got a section where you can put your R functions, and then that man section, and this is straight from our packages, but the man section is where you can document those to explain how they're working. And then the license, you can give information if people want to use your code about what license it's under. So they feel like, you know, they can reuse it in a way that's fair and equitable. And with a lot of our stuff, typically that'll be an open source license at that point. But this allows somebody to actually be able to feel comfortable reusing your code. So it's a really good read. He's got a few other structures that he suggests as well, but this, again, I think is a good starting point. All right, so to sum up that section, first rule, try to get them all in one directory. There's some big advantages to that. The second, as you design a system, think about one that's easy to use, easy to reuse, and easy for somebody else to discover how to use it. And then the final, if there is a standard system, use that standard system. If there isn't, invent one for yourself and use it across all of your projects. There's a big gain to that. All right. So now we'll go into just some slightly more advanced stuff, because you can do fancy stuff once you start doing this. And that's a lot of fun when you get into that. So the first is the idea of coding to a standard directory structure. So this is also from the Marwick paper, and it talks a little bit about how this compendium can kind of organize files, and you can do it based on standards, right? And then at the very end, I've highlighted this. One of the key parts, once you have the standard that you keep using, is that you can start to build tools that work with that standard. One of the other commentaries talked about a little bit, and I think that they had a good comparison. So this is an example of a bunch of files, and a lot of times you might end up with a lot of files that are all the same type, but they're maybe for different experimental units or something. So this is an example from a student. This is flow cytometry data that she had. And as you look through those file names, each of those is from a different mouse that was tracked. And some of those mice were given BCG, which is an old but still in use vaccine for tuberculosis. Others were given just saline, and then the samples were taken in the spleen or they were taken in the lungs. So you can see there's some information about that in there. So the analogy about doing things programmatically with these kinds of files, when you start to do things programmatically, it's like all of a sudden you're like what is it in Fantasia, the Mickey Mouse, when like, you know, the Sorcerer's Apprentice. You've got that kind of feel, like all of a sudden you can do something, and sometimes it'll mess up just like it does for him, but you get all of this power all of a sudden. So he gives the analogy to like the first time you figure out you can select a bunch of files all at once, right? Just with doing your cursor. And then you can, instead of moving file, if you need to move 100 files, instead of like dragging them one by one, you can like drag the whole thing. That's the feel of it, right? So one way that you can do that, one example, there's so many of them and they come up, they're kind of like piecemeal as you do it, but you just come into them again and again, but you can start using regular expressions with your file. Let's say you have put all of your data with flow cytometry under your data file, and then within that, under a subdirectory called flow cytometry data. You can start to write functions, and R can do system calls. R can do anything that your computer can do. R can erase every file on your computer. I know one case where that has happened. R is very powerful because it can do those system calls. Don't worry, like it's very hard to do, but because it can do that, it can do all of these cool things. Like you can give it a directory that you want to go to, and it'll give you back a list of every file that's in that directory. So in a case like this, you could do one call where you create an object that lists every file that you have in that directory. Then you can use tools from things like purrr, and you can do the same thing to read in data from all of those. including the file names from all of this. And then if you've done clever things with how you name your files, you can use regular expressions to pull that information out. So you could get your columns that say, was this the spleen? Was this the lung? Which research animal was this? So you can start to do things where you're not having to copy and paste a lot, you're having it work with that. And then when you have the next experiment, where maybe like, instead of day 30, that's that D30, maybe now you're at day 45, your code can run on the new, you develop it for one and can run on the new, because the input you're giving it is where to look for the data. And as long as your data is saved in a similar format, it'll work for that. In some types of research, you can really go a long way with this. So this is an example, I showed this a little bit earlier, but this is an example where it's an experiment in immunology. And it's a very like well-controlled experiment, right? It's very hard to run the experiment, but then the data analyzing and all is very straightforward once you get it, because you're not having to control for a lot of confounders and do a lot of things like that. Really, like the tricky parts are in collecting the data in the first place. So what we were able to do with this is we didn't just design the directory structure, we also designed some template files for working with it. One of them was for how people recorded the data. So this recorded data was for recording the colony forming units from the tuberculosis, the CFUs, and that's a measure of kind of how much bacteria was growing in the lungs of each animal. And that's something collected in the lab, but we created the way that it should be recorded, like a spreadsheet for how you put it in. So each new project can use that one. And that enforces that things will always be in the same place for all these different projects. And they were doing this kind of research where they were testing a lot of drugs. They had like 20 different experiments that they were doing, where each one was testing a different drug or combination of drugs, but then the method they did was very similar for all of them. So we did that with these kinds of templates, and then we could also design a report template that reported out some of the key pieces of information that they wanted to have. And because you're always putting the data in the same place in the same format, we could write that once, and then every time in the new project it gets copied in and it runs, because stuff is in the place you expect it to be. So how this worked in practice was when they started a new project, they could copy this all the way through, rename it, they're ready to go. When they record the data, they open the template for doing that. We took the example of R Markdown. With R Markdown, when you open it up, it gives you an example, like an example stuff, and you delete all of that, and then you put the stuff you want. But the reason it's got that example, it serves as a starting point for you. So you don't just have the instructions for how to fill it out, you have an example right there. So we did the same thing, but did a different color of the text, so it was clear that you need to get rid of this and replace it with your own. And then the report is an R Markdown, and you can customize it however you want, but out of the gate it runs. If you put the data in the place it expects the data to be in the format it expects the data to be, then at that point everything runs quite smoothly. All right, so this is the last thing I have to talk about. But another fancy thing that you can do that's sometimes worth the pain and maybe sometimes not, you can actually create your own R project template. So, I'm saying all of these words, like I talked about a project template where you just have a directory that you copy, rename, and use. But if you want to, you can make it so when you open R, it is a project type that you can choose from. And for something simple, it's probably really not worth the pain. You were talking about having something that has its own file to it. So once you start adding layers like that, it makes sense. If you ever do book down or packages or something like that, a lot of times this makes sense, and people have already made stuff for those. So when you go to make a new project in RStudio, you can select like that generic new project, right? But then you also have some templates, and which ones you have depend on which packages, because these all come, like they're created in a package. So to get new ones, you install new packages and then they show up here. But, if you wanted to make an R package, you open that specific one, and instead of it just being a blank directory, it comes populated with these things that are in the right structure. And so you can do that. You can do that yourself too. When you do that, it shows up kind of like this. This is one that I created for that immunology drug testing project. So you have that as a choice, and then you can even set up this wizard so that the person inputs some stuff, and when it creates it, it'll populate with that. So for example, they could put in what the name was, but they could also put in if it included certain types of data, and then you could go from that. So I'm let me see, I'm gonna try to do a demo on my computer, and I think I need to stop the share and share everything probably. Yeah. There we go. All right. So a lot of times these kinds of templates, especially doing those template files, a clue that you might want to do it is when you need to copy and paste a lot. So this is a little bit of a toy example. I haven't used it in practice yet, but I thought it was a fun one for those of us who are in the research world. Okay, so think about the last time you had a lot of text that you needed to copy and paste from one place to another. And Robbie, I'm going to ask you, in the last 2 or 3 weeks, has there been any example where you had to copy a lot of text from one place to another?
Yes, yeah, so.
This is not rehearsed, by the way, so we'll see. This might be a surprise, but I think I can pull it out of you.
Yeah, absolutely, yeah. So I've just finished writing a grant with the people here and so.
When you write a grant
Yeah.
proposal, I mean, maybe some in like the body of the proposal, but like the sections of like your research environment and
Right,
your,
right.
okay. So I thought
Not
it
that I would
would
ever
be,
just copy and paste it.
well, I thought it would. You can have your own art template for that.
Whoa.
So let's go in. And let's say, should we
Whoa.
write an R01 grant?
Whoa.
My favorite part is I got the money icon by it. All right, so let's see. Let's do one on disasters and birth outcomes. I'll be the PI, sorry.
Okay.
But we'll have some human subjects, right? Okay.
Nice.
And let me look around for my bio sketch.
Whoa.
Why was so fun?
Yeah. Wow.
Work.
I didn't know you could do that in hospital.
All right. So we have our project now, and you can see that it is populated with things that I need. So part of that wizard, it asked where my bio sketch was. You can see we've got my bio sketch in there. CSU has some forms we have to do when we're starting stuff out. I always have to look through all the emails to find that. Not anymore. There it is. If I want to add in data, I can add in data. I've got a space to put my figures. I've got a space to put R code. And then down here in writing, I have populated that as
You've already
well
done it.
with some examples. So in my research approach, I took the example of R Markdown in general. It's not just blank, because sometimes you forget how to put the figures in. Sometimes you forget how to put the different, right? So this is R Markdown, but I'm getting into LaTeX with it because I want it to look fancy, right? So you can put in, and I put in figures from old proposals, not because I want to reuse them, but because I want to remember how do I put in a figure and put the label right. This is super nerdy, but you can see here, I even put in lorem ipsum. Does anybody know what lorem ipsum is? Yes. Okay, so it's something, it's like fake language that people who are developing web pages use to show what it would look like once it has language in. When I write things, I tend to write like 12 pages when it's 6. And so I've started for some stuff, populating it with the word count or the page count of lorem ipsum, and then I just replace instead. Yeah. Yeah, so we've got all of that here, kind of ready to go there. We've got down here our research environment. That's filled with real stuff because we tweak that depending on the grant, but not a lot. Like which computer CSU has for their supercomputers, that doesn't change that often.
Mm-hmm.
So yeah, we've got all of that stuff here. So yeah, kind of ready to go on all of this front. Yeah. So I mean, this looks all super fancy and everything, but like the fancy part is I made the magic with R, but you could just do this as a directory that you copy and rename and start from, and you all already know how to do that, right? So yeah, It's not magic, it's just sounds like magic. All right, so if we go back in. Last slide that I have, but I can show you just a little bit about what it looks like to actually make one of those. And then I've got a link later for how you can do it. This is still like, kind of, it hasn't taken off loads. Because again, like the example that I just showed, it looks very cool and shiny and all of that, but you could do the same thing, making it, copying it by hand, renaming it and going from there. So it is more the cases where you have a whole build file that you want to do, where it starts to make sense to do it. So most of the ones have been built like by our studio teams, right? So some of the instructions are still a little arcane. There aren't like loads of tutorials out yet that walk you constantly through each step of the process. But if you've done a package before, it's not crazy to figure out. And it is making a package. So it's based on that R package thing. And what you do is in our packages, you can have this inst file that kind of serves as a catch-all. So you put in your different template files in that catch-all space. And then the R code is pretty much like setting up, it's copying it in when it's ready to go. And it can customize some stuff based on what you put in that wizard. So like when I told it the file path to my biosketch, it was using that to populate that in the right place. But again, it's taking advantage of R being able to use system calls to create new directories on your computer and to copy files into them and you know, like even write extra stuff into the parts of those files. So yeah, you can certainly do it. Again, like you don't need to in a lot of cases, but it's there if you ever want to. All right, so I've included some of these resources, things I would strongly recommend. Certainly the Adam Savage book is a good read, and also I thought was a great one for thinking about stuff. And then that Marwick paper, I think is a great starting point for people who use archive to think about how to organize. And then if you do want to try out making your own art project template, I've got the link for that as well. All right, so that wraps up my presentation. I feel like I've done magic.
I don't really have, well, I guess it's not really a question. I mean, it's a question, but I like when you put your example of like this, the red text, this is what you change, or this is your new one.
Yeah.
And to your point about that, there's not a lot of tutorials, because there really isn't. And the ones that are out there, they don't tell you what you actually need to change. So for people that are still learning, even like the templates or how to navigate this, that's where they give up, right? Because they don't know what part are they supposed to change and what part you're not supposed to change.
Yes.
And that is that I think is what I found is like one of like the bigger like first more on like the R template, like you know, navigating those, but you're right, there's like not tutorials, it's not very informative. Like there's
some areas of art where there's loads of stuff, but some of the stuff that's still like emerging.
Yeah.
You know, yeah, sometimes you go in and you're kind of like discovering it, you know. Yeah.
That's fun. I gotta run.
I think with what I saw that in your lab, you end up by having like the manuscript written and also even the references and the code, like everything in the same folder.
Yes.
Do you do that?
Yes, we do. And I was showing some of
why, because like for me, it's like the code is in one side and then the writing is in somewhere else.
So I do a division within the subdirectories.
Mm-hmm.
But I want all of the files for that project in one place.
Mm-hmm.
You saw my office. I want to be able to find things on my computer because I can't find it in my office. I mean, it keeps things in one place, but also when you start using R Markdown and things like that, you can do relative path names to get from the thing you're writing to your data and back, even for the grant. You know, if I'm writing a table or a figure for the grant, I want to put that code there. So when the grant, you know, doesn't get discussed and I need to rewrite it later, I could go back and figure out how to redo that particular figure. Because if I have this stuff somewhere else and you just have the output where you're writing things, yeah, but if it's all in one place, I can go back in a year and not have looked at it and yeah, thank you, past me. Like I can find where things are. So yeah, in terms of the path names, when you have it there in that same directory, you can do a relative path name. And when you do that, it becomes like the pod, right? You can share that whole directory with someone else and it'll run on their computer. Because like everything that you need gets chopped down from there down. And with the relative path name, it doesn't matter how the rest of their computers are organized. It's just how that directory is organized.
We have a question online. Yeah, comment and question. Thank you so much for sharing. This is amazing and eye-opening. I wonder how often and how much efforts are needed to make updates and customize if the grant mechanisms are different.
Oh, for the grant one specifically. Well, I mean, page links. But a lot of things, it would be more of a difference if you're going from one organization to another. So like it would be a totally different one for NSF. But some of these ideas come through from the LaTeX world where there's been a lot of development of templates. And in some cases, journals will even have those. And there's one really cool package in R called Articles, which is spelled like articles, but without the A. And it has these projects, like these templates, it has them for different journal articles. So like there's a PLOS one and you can set up for that. A lot of the stats ones for the art journal, if you're ever writing the art journal, and then some of the big like families of journals, and I can't remember which one. So every journal doesn't accept those, but among the ones that do, when you write it, you can do everything in R Markdown, but when you generate the PDF of it, it looks like the final thing's gonna look. And often the journal will take that as the input, like it'll write out the LaTeX files of it too. And so it'll take the LaTeX files as what you submit, which saves you a lot of time when you get to like the proofing stage of it, because they just use that and you've already seen it, so you've already gotten the chance to proof it at that point. And I think reviewers tend to be happier when they see something that looks like the real thing rather than like Word, double space, you know.
That's true. I have a question about when you're making a project and you've got the data. So like when I use GitHub, the main issue I always have with GitHub is files that are big. So like
Yeah.
you suggest keeping them all in one place, but then for two reasons. One is that you're using it over multiple projects, but the second is if you can't push it to GitHub. Like, what's your
And there's even another one, sometimes you can't share the data. You can't put
right?
it on
Right.
Okay, so there are a few things. I think GitHub has some different functions for large data sets, and its capacity is actually fairly large, but sometimes you do run into things that don't fit. And you know, if it's private data, like it's a no-go. But what you can do there is a git ignore file, and you can have git ignore certain files. And so for some of those cases, it makes sense to have things local to computers of different people who are working on it. And the part that you're pushing back and forth to GitHub is only the code.
Yeah, but I just mean, do you manually drag them across different computers there? If you ignore that you need it.
Yes, for that one, you would do it that way. The other thing, if you have data that you are reusing for a lot of projects, and this will seem obvious as soon as you hear my answer to this, but if you have data that you are using for a lot of projects, the best thing to do with it is to make an R data package out of it. And
there you go.
just do the library for that every time you do it. And it also works working across collaborators.
Okay.
Because you don't have to copy, like you've used that data in some papers for the exposure. And you have not copied it from place to place, have you? Yeah. Plus, that way it's versioned. And that way it can include documentation. Same if you find yourself using R functions over and over. Make a package. Like a package. Do you have to come back and do that sometimes? Writing an R package if you were coding a lot in R is not. It's a lot of like bookkeeping the first time you do it to figure out where things go in the right place.
But a package could be just internal, right?
Yes.
It doesn't need
Yeah.
to be-
Yes.
To give your functions and
Yeah. So kind of, yeah, anybody who's written a package, like, will tell you it is much easier than it seems like before you have written a package.
Yeah, I think it feels intimidating, but then you just got to do it.
It's just a directory where you put things in places that have rules to them about like where you can put things and where you put in and what you need to put in.
Question. Do you have suggestions about, I know this is all very helpful for managing collaborations, and I'm wondering if, for example, I'm working with a lot of files created by other people. I want to be able to continuously incorporate their updates, so I have a Git fork, but I'm also trying to create my own work. Do you have tips for organizing. you
So
know,
wait,
your-
so, okay, so you're pulling the files that they have.
Right,
but
but
then
then
you're
you're
adding
modifying
stuff to
them and trying to,
Do you
Keep
put,
my
do you
kind of-
push back, or you're just like,
yeah,
they have their thing, and then you're just, oh, that's interesting.
yeah. And keeping it organized is challenging, so you should keep track of that, well, when did I clip this from this source and that kind of thing, so under getting wisdom for that.
That is a good question. There would be a way to automate it. I don't know if it would be worth it, if it's like a single case. Or if it would only be worth it if you are doing that a whole lot of times, but. I mean, with computers, you can set up things called cron jobs where like every night it checks, and if it's updated, it could. Pull your new thing and it could write into like a log file you keep when it got new data. So there's some things like that you can set up that are more at that level, but again, like it's the kind of thing that doing it by hand will be the quickest thing to do for a certain amount of time. In terms of kind of the management, I would think about it more to design a full system, but there might be a way to set up a directory for your project where everything goes into the same directory, but you have it split very cleanly into parts, where one part is the part that you're getting from outside with the get stuff, and then the other part is the part that's got your work. But still, by keeping it in that same one, you can start to do your relative path names so that you go across. You're welcome.
One more question, if you have it, otherwise. I should also say, I mean, this is just a preview of the sharp course, or kind of.
This is a topic. I
Yeah,
think that
so-
we'll be
so-
covering
So
some of
Brooke's running a sharp course on code.
code rigor and reproducibility, yeah.
Some
More magic.
more, yeah, more magic. Yeah. Well, it's different from magic because the more I learn about it, the more magical it gets. Whereas usually I'm like, oh, it's someone's hand behind it. But this is,
But the real magic is like when you build it and then you get it to running, you know you built it.
yeah. Well, thank you so much, Brooke.
Yeah,
Thank
thank
you.
everyone for your interest for coming.
Yeah.